So first we'll start with the vision of this program. So NEET reactor materials will enable the development of innovative and revolutionary materials and provide broad-based modern material science capabilities that will benefit DOE NE's mission. And the key words here are innovative and revolutionary. Once we talk about a little more about the details of the solicitation, I will attempt to quantify what innovative and revolutionary means. But at this point, I will talk about what it is not. Revolutionary would be the opposite of evolutionary. And so there are a lot of material systems that could benefit from evolutionary gains, but this program is not the place for that research. That type of research is better done within the other NE applied programs. Also with the word innovative, what it is not is taking a material technology that was developed maybe up to 75% of the way and now picking it up to complete to get that to a qualified material. While these are worthwhile research to do, it's not what this program is geared for. So program outcomes. This year we had a solicitation that covered both research and infrastructure needs. This solicitation focused on advanced joining technologies. Advanced joining technologies was chosen because it was identified that with advanced materials, we need to develop advanced joining techniques in order to make these materials useful in an engineering environment. The second portion is of that solicitation, we also had a competition for the acquisition of analytical capabilities needed to support modern material science research at the national labs. We also host an annual NE coordinated materials research meeting via a webinar, and this gets all of our researchers together to talk about what research is going on, what's planned, and what the state of the art currently is. Next year, we will continue, as you will see once this solicitation is released, to compete research on innovative materials. I'll talk more about this shortly. And also, the second portion of that is for infrastructure analytical capabilities at the national labs. And again, we'll host the annual NE Coordinated Materials Research Meeting. The NEET Reactor Materials Program was started in 2012, and that's when we had our very first competition. The focus for that competition was on advanced materials development. We funded 9 proposals. Those proposals will be completed in 2015. And as you see, our topic again is the same as it was in 2012, advanced materials development. So this chart shows you how we envision some of these projects transitioning and some of the new projects that we will fund in 2015 to transition. So the idea is that some of the awards that we made in 2012 will still need some additional research in order to fully flesh out the materials technology. And those can be submitted part of the solicitation, and we'll compete with new ideas. It's also envisioned that some of the concepts that we funded in 2012 will now be of interest to some of the NE applied programs and can be funded under those programs and the technology tailored for particular reactor systems. Because of the cross-cutting nature of the research that's done in NEET reactor materials, we have a lot of coordination across NE on both the federal and the laboratory side. And so this slide gives you an idea of all who we're coordinating with to both identify the topic and identify what is of interest for funding our research. So we have 2 competitions. The first one is the research competition. This is open to industry, universities, and national labs. In this area, we're seeking applications for advanced materials discovery and development. And this is where we attempt to quantify what revolutionary means. And improvement in mechanical performance by a factor of 5 to 10 over traditional materials, increasing maximum operating temperature, increasing radiation tolerance to beyond 300 dPa. So that's the type of material performance that we're looking for when we say revolutionary. And another thing I'd like to emphasize is that proposals should be of a cross-cutting nature. So the material system that is proposed should be of interest and of possible use in more than one type of reactor design. There's a material system that would only be of use in, say, one reactor design, maybe the sodium fast reactor, then that research should be done in the advanced reactor program. But materials that could be useful across many reactor systems, those would be perfect for this area. So we're looking for high-risk, high-reward transformational concepts in the NEET reactor materials research solicitation. The second portion is the infrastructure competition. This is open only to the national labs, and it was developed as a counterpart to the NEET infrastructure solicitation. So this is to acquire key components to modern material science and to acquire new tools that can be used by NE's research community. And so the goal here is to purchase strategic investments. And so you'll see when the solicitation comes out, one of the criteria is talks about the need to show how any new acquisition could benefit materials research across the NE complex. And that's quite key here. So we can have a lot of great equipment, but if it's not focused on what type of information we need in the nuclear area, then it's not of use to us. So that's very important. And here's our contacts. I'm going to take questions in a moment, but if any questions come up after this webinar, feel free to email myself or Jeremy, and we'd be happy to talk with you on clarifying any topics, and if anything comes up after this webinar. Take any questions if there are any.
We don't currently have any questions. Please submit any questions you may have for Sue in the next few minutes. While we're waiting, we can mention that something that is new this year is in this area, national laboratories are able to do a joint R&D and infrastructure proposal, or just an individual R&D or an individual infrastructure proposal. So that's a new change to the FOA this year. Sue, the first question. Can you identify or outline the innovative materials that are needed for further research?
There are many. We have some examples that will be in the solicitation, but I can't point to any specifically. We're looking at metal alloy systems that have increased radiation resistance that can be used at higher temperatures over longer periods of time. We're also looking at composite systems. We also funded in 2012 a polymer system for cabling. So any of these material systems are of interest.
What specific aspects of mechanical performance are important?
The important characteristics are the ones mainly for mechanical behavior. So this is creep, fatigue, strength, thermal stresses, mechanical stresses, and of course radiation resistance.
How do we establish relevance for the proposed activities?
A good way to do that is to, one, there'll be a lot more details in the solicitation. And the other way is to take a look at our nuclear energy website. all of the programs, the research programs, the applied programs, have sections in the website, and you can get more details and reports there on what is of interest in each of those areas.
Is additive manufacturing of interest in this topic?
This topic mainly focuses on material discovery and development, so I don't see how that would be part of the scope.